I'll be teaching you how to do the rules of exponents. Okay, let's get started. The first rule I'll be doing is division. Dividing exponents is probably the easiest one to do. At least for me it was. So, basically, in dividing exponents, you have a problem like this, and you cancel out the exponents with the same variable. So that means x to the 6th, and under it would be x to the 2nd. So that would make it you would cancel them out, which would leave a to the 4th on the top, because there's more on the top. Now, for b, it's b to the 5th power over b to the 9th power. So that would be crossing them out, and that would leave you 4 b's on the bottom, because the number on the bottom is larger than the one at the top, so there would be more left over on the bottom, which would make it the bottom one, having leftovers. So a to the 6th, b to the 5th over a to the 2nd, b to the 9th equals a to the 4th over b to the 4th. The next one I'll be teaching is addition. Adding exponents are pretty easy, as long as you remember what to do. So, suppose you had a problem like this. 2a squared plus 3a squared equals what? So, you can add the binomials if the exponent is like. So, that would mean 2a plus 3a squared, they're both squared. So 2a squared plus 3a squared would be 5a squared, because you're adding these. But if your problem was 2a squared plus 3a, it would just equal 2a squared plus 3a, because they don't have like exponents. So basically, you add the binomials, these, if the whole binomial has the same exponent. But if they don't have the same exponent like those, it would just equal the same thing until you found out what a or x or whatever variable you had equaled. Okay, so my next one is subtraction. Subtracting exponents is almost the same as adding except subtracting. So, again, if you had 2a squared minus 3a squared, it would equal negative 1a squared, or negative a squared. Because since they have the same exponent, you can add the constants because the exponents are alike. But if you had 2a minus 3a squared, it would just equal 2a minus 3a squared. So adding and subtracting are basically the same thing, just changing these. So last thing is multiplication. And multiplication has multiple parts to it because, well, it's multiplication. So the first one is squaring stuff. So if you had a problem like this, 2a squared, you would only square the a because in multiplication, each part of the polynomial has its own exponent. So this 2 would be like have only 1 because it would be 2 to the first power, so that would be equal 2. So and the a has a squared, so it would be a squared. But if you had the quantity of 2a and you're squaring that, you would square both the 2 and the a because the exponent is outside of the parentheses and you square anything in the parentheses. So like that, 2 times 2 would be 4, and then a squared. So the quantity of 2a and then squaring it would be 4a squared. Another multiplication one is like this. Suppose you had 6a cubed times a to the 4th. You would add these exponents because in a multiplication problem you add the exponents. So the answer would be 6a to the 7th. One of the next ones is distributing. So this is a simple one. The quantity of a to the 3rd and squaring that would be a to the 6th because you distribute the exponent to the exponents of the things in here. So doing the more complicated one, it would be the quantity of 2a squared, b, c squared, and squaring all of that. You would have to distribute the 2 to every part inside the parentheses. So 2 squared is 4, and then a squared, and squaring that would be a to the 4th because, like in this one, you just multiply these, the exponents, and for these real numbers, you actually like square them or do whatever the variable says. So, and then b squared would be b squared, and then you would multiply 2 and the exponent of c, which is 2. So you would 2 times 2 would be c to the 4th. So your answer would be 4a to the 4th, b squared, c to the 4th. That's all of the rules of exponents. I hope you learned a lot.
Thanks for teaching me.